fractions, rational numbers. Source code lib underscore fractions.py. The fractions module provides support for rational number arithmetic. A fraction instance can be constructed from a pair of integers from another rational number or from a string. Class fractions.fraction numerator is equal to 0, denominator is equal to 1. Class fractions.fraction other fraction. Class fractions.fraction float. Class fractions.fraction decimal. Class fractions.fraction string. The first version requires that numerator and denominator are instances of numbers.rational and returns a new fraction instance with value numerator divided by denominator. If denominator is 0, it raises a 0 division error. The second version requires that other function is an instance of numbers.rational and returns a fraction instance with the same value. The next two versions accept either a float or a decimal dot decimal instance and return a fraction instance with exactly the same value. Note that due to the usual issues with binary floating point, see floating point arithmetic issues and limitations, the argument to fraction 1.1 is not exactly equal to 11 by 10, and so fraction 1.1 does not return fraction 11.10 as one might expect. But see the documentation for the limit denominator method below. The last version of the constructor expects a string or Unicode instance. The usual form for this instance is sign numerator divided by denominator, where the optional sign may be either plus or minus, and numerator and denominator, if present, are strings of decimal digits. Underscores may be used to delimit digits as with integral literals in code. In addition, any string that represents a finite value and is accepted by the float constructor is also accepted by the fraction constructor. In either form, the input string may also have leading and trailing white space. Here are some examples. From fraction import fraction. Fraction module. Example 1. So fraction minus 8.5. Fraction 1 2 3. Fraction 1 2 3. Print 1 2 3. Fraction default. Default is 0 by 1. Fraction 3 by 7. Print fraction 3 by 7. Fraction minus 3 by 7. Print minus 3 by 7. Fraction 1.4 tab. Print 1.4 tab n. Fraction minus 0.125. Fraction 7e minus 6. Fraction 2.25. Fraction 1.1. From decimal import decimal. Fraction decimal 1.1. Run. Minus 1.8. Here I did not print, so let me print it. Run. 11.1. The fraction class inherits from the abstract base class numbers.rational and implements all of the methods and operations from that class. Fraction instances are hashable and should be treated as immutable. In addition, fraction has the following properties and methods. Numerator. Numerator of the fraction in lowest term. Denominator. Denominator of the fraction in lowest term. As integer ratio. Return a tuple of two integers whose ratio is equal to the original fraction. The ratio is in lowest terms and has a positive denominator. Is integer. Return true if the fraction is an integer. Class method from float FLT. Alternative constructor which only accepts instances of float or numbers.integral. Beware that fraction.from float 0.3 is not the same value as fraction 310. Note: from Python 3.2 onwards, you can also construct a fraction instance directly from a float. Class from decimal dec. Alternative constructor which only accepts instances of decimal.decimal or numbers.integral. Note: from Python 3.2 onwards, you can also construct a fraction instance directly from a decimal.decimal instance. Limit denominator. Max denominator is equal to 1,000,000. Finds and returns the closest fraction to self that has denominator at most max denominator. This method is useful for finding rational approximations to a given floating point number. From fractions import fraction. Fraction this limit denominator 100 1000. Example 2. Let me print it. Three five five one three three. Or for recovering a rational number that is represented as a float, from math import pi cos fraction cos pi 3. Fraction cos pi 3. Fraction cos pi 3 dot limit denominator. Fraction 1.1 limit denominator. Underscore float returns a greatest integer less than equal to self. This method can also be accessed through the math.float function. From math import float. Seal returns the at least integer greater than equal to self. This method can also be accessed through the math.seal function. Round n digits. The first version returns the nearest integer to self, rounding half of to even. The second version rounds self to the nearest multiple of fraction 1, 10 power n digits. Logically, if n digits is negative, again rounding half toward even. This method can also be accessed through the round function. Format specs provides support for float style formatting of fraction instance via the str.format method. The format built-in function or formatting string literals. The presentation types capital E, F, capital F, G, capital G, and percentage are supported. For these representation types, formatting for a fraction object X follows the rules outlined for the float type in the format specification mini language section. Here are the examples. Example 3. Format print F. Format fraction 17.40z. Format supported format string passed to fraction. Let's do it. Okay. So this is the scenario.